The next wave we're studying on the ECG is the S wave. And every time we look at any wave, we're just trying to define it, where you can find it on the ECG. Then we're talking about the normal wave, how the normal one will look like. Then we're also looking at what? How the abnormal one will look like. Okay? So the S wave in electrocardiography. That's what we'll be looking at. So in here, you see the QRX complex. QRS complex. Alright? QRS complex. That's what we'll be looking at. So the S wave in electrocardiography represent the final downward deflection of the QRS complex. Right? So this is Q, this is RS. So the final going down of this complex is what is known as a QRS. Right? So they represent the final downward deflection of the QRS complex, indicating the completion of what? Ventricular depolarization. Because the whole QRS complex what shows that there's a ventricular depolarization, with the Q showing the onset of ventricular depolarization, R being the middle, then S showing that what the ventricular depolarization is done. Alright? So going into the things now, looking at the normal and the abnormal. Okay, S wave. So for the normal S wave, it has these characteristics. For the time it will last, or the duration, is less than 0.04 seconds, right? Amplitude should be less than what? 1/4 of what? The R wave amplitude. Let's talk about this logically. So let me see something. So this is the R wave, right? So the R wave is as tall as this. So this simply means that what? If you divide R wave into 3, this segment should still be bigger than the segment for what? S wave, which is okay. Or you could say S wave is starting from here to here. Not really from here to here. I think this down one was just for the drawing error. Yeah, this shows a normal S wave. So that simply means if you divide R wave into 3 compartments, it should still be more than the S wave. Okay. So you see that the amplitude is what? The amplitude should be less than 1/4 of the R wave. Present is normally present in leads 1, leads 2, lead 3, ABL, and V6. Right? Then that's a normal S wave. Right? How it should be normal. Then for the abnormal S wave or pathologic S wave, if you're having a deep S wave, that means what? It is more than what? 1/4 of the R wave. If you divide R wave into 3 parts, each of the parts will still be bigger than the S wave. Okay, that's the deep S wave. This indicates that there's what? A ventricular conduction delay or hypertrophy. Okay, there's ventricular conduction delay because this thing is ventricular depolarization. So that means the ventricular depolarization is not occurring ASAP. It's not occurring ASAP. That's why you're having a deep S wave, right? Then for the wide S wave, this is when the duration for which the S wave is occurring is more than what? 0.04 seconds. It indicates that there's a ventricular conduction delay or any aberration, alright, aberrancy. Okay, then you have the persistent S wave. This one, it's present in leads where S wave are normally not seen, and this indicates that ventricular conduction has an abnormality. Alright. So S wave abnormalities can indicate various cardiac conduction such as what? Ventricular conduction disease, ventricular hypertrophy, cardiac arrhythmias, myocardial infarction, or any cardiomyopathy at all. Alright. So if you see any abnormal S wave, you need to what? Investigate it. Alright. So this is what the note on S wave that could be seen in what? Electrocardiography. Alright, focusing on the normal S wave, abnormal S wave, of pathological S wave. Good luck.